Okay, let's go through the homework. I don't remember if it said calculator inactive or calculator active, but just the way this question is written, using your calculator is irrelevant anyway. So question 1, we got to do a tangent line, so we know we're looking for y equals y1 plus m x minus x1. To get our m, we need to think, what is k prime of 3? K prime of x is f prime g of x, g prime of x, just good old chain rule. So k prime of 3 is f prime g of 3 times g prime of 3. Oops. Let's make that a 3. And we can just get these from the table. G of 3, where is it? G of 3 is 6. F prime of 6 is 5. And then G prime of 3 is 2. So we got 10. Now to know our y value is going to be k of 3. So while we're at it, let's go ahead and work out k of 3. So let's work out f of g of 3. We already said g of 3 was 6, and f of 6 is 4. So let's say it's going to be y equals 4 plus 10, x minus 3, smiley face. H prime of 1, well, this is just doing the quotient rule. So this question is really just testing, do you know some derivative rules? And use a table to prove it. Also tangent lines. So h prime of x, we're going low d high. So low d high minus, let's make a little room. Pardon the interruption, pardon the interruption. That's a little DSA announcement joke. F of x, g prime of x, minus low d high minus high d low. Over low low. So over f of x squared, or f squared of x if you're fancy. I am not fancy. And then let's just plug in our numbers. We've got to do h prime of 1. We shouldn't use the equal symbol, just kidding. What we should do is now say h prime of 1 equals, right? You don't want to say equals and then start plugging in numbers. That's bad. Looks wrong. Let's see, f of 1, negative 6, times g prime of 1, 8, minus g of 1, 2, f prime of 1, 3, divided by f of 1 squared, so divided by negative 6 squared. And let's see here, probably some parentheses there. And I think it's probably all we have to have. Negative 48 minus 6 divided by 36. I think that's right, negative 54 over 36. Both divisible by 6, I believe. I think this becomes 9. Ooh. Both divisible by 18. I think this is negative 3 halves. All right. Then the last one is evaluate the integral from 1 to 3, f double prime of 2x dx. All right. Let's get some draw in space. So this is just a variation on fundamental theorem of calculus. We know that the integral from a to b of f prime of x dx is f of b minus f of a. So traditionally, if our integral uses prime, then for our antiderivative, we just want to take away the prime. That's kind of what anti-differentiation is, right? Reversing the prime. The trick to this one is to recognize, okay, the antiderivative here is f prime, but since there's a 2x right there, we want to go f prime of 2x divided by 2. Right? That is that use substitution shortcut that I preach over and over, that if you have a linear expression in place of the x, you have to divide by the slope of the linear expression. That's always true. That's even true in this function notation question. All right, and if we do that, the rest of this is going to be pretty easy. This is going to be f prime of 2 times 3 minus f prime of 2 times 1, divide by 2, divide by 2. All right, f prime of 2 times 3 is f prime of 6. F prime of 6 is 5. So 5 halves. F prime of 2 times 1 is f prime of 2. That's negative 2. So minus negative 2 over 1 over 2. That ends up being plus 5 halves plus 1, 7 halves. I think that's good. That should be a 9 out of 9 and a pretty easy, fast question. I hope this video didn't take as long. I'm always surprised when I hit stop. And I think the video lasted 10 minutes and the video really lasted 20 minutes. We shall see. Say goodbye. Bye.